Okay, this is number 59 for chapter 6. The expression F equals ARV plus BR squared, V squared gives the magnitude of the resistive force in newtons exerted on a sphere of radius r in meters by a stream of air moving at speed v in meters per second, where A and B are constants with appropriate SI units. Their numerical values are A equals 3.1 times 10 to the negative 4 and B equals 0.87. Using this expression, find the terminal speed for water droplets falling under their own weight in air, taking the following values for the drop radii. A 10.0 micrometers, B 100 micrometers, and C 1 millimeter. For A and C, you can obtain accurate answers without solving a quadratic equation by considering which of the two contributions to the air resistance is dominant and ignoring the lesser contribution. Okay, so let's start with part A. So we're given the expression force equals ARV plus BR squared V squared. So we want to find the terminal speed, so we want to find V. But it says in the question that we can ignore one of these two parts depending on which one's more insignificant. So first, well, we know that F equals mg in this case because the droplets are falling and gravity is the only force acting on them, on the water droplets, and so that equals ARV plus BR squared V squared. So the only thing that we don't know in this equation is V, which we're trying to find, and M, which we should have. So remember that density equals mass over volume. So mass equals the density times volume. So the density of water is 1 gram per milliliter. And then you'll multiply that by the volume of a sphere, which is 4 over 3 pi r cubed. So the radius is 10 micrometers, and if you multiply micrometers by 10 to the negative 6, that'll give you meters. And then you have to cube that because that's part of the equation for volume of a sphere. And then 1 milliliter is equal to 1 cubic centimeter. And there's 100 centimeters in 1 meter, but they're all cubes, so you have to cube this. And then this will give us the mass of the water droplet in grams, and we want kilograms, so we say that there's 1,000 grams in 1 kilogram. That cancels, milliliters cancels, centimeters cubed, meters cubed, and we'll get left with kilograms, and we'll get that the mass is going to be 4.189 times 10 to the negative 12 kilograms. So if we look at this equation, we have to decide which one we're going to eliminate. Since the radius is so small, if we square it, then this is going to be a really small number. So we'll take this out and say that V then equals mg over AR. So you just plug in the numbers. So mass is 4.189 times 10 to the negative 12 kilograms times 9.8 meters per second squared divided by A, which is given in the problem as 3.10 times 10 to the negative 4th, and then divided by the radius, which is 10 times 10 to the negative 6 meters, because that is 10 micrometers. And then so the velocity is going to be 0.0132 meters per second, And we see since the velocity is less than 1, if we had used this part of the equation, then this would have been a really small number anyways. So that's the answer to part A. Now to part B. So this is when the radius is 100 micrometers. So we have F equals ARV plus BR squared V squared. And both of these terms are going to be significant, so we're going to have to use the quadratic formula at some point. So mg equals ARV plus BR squared V squared. If we move this around, then we get BR squared V squared plus ARV minus mg equals 0. So we have our quadratic equation, and except for the velocity and the mass, but we have to find the mass. So the mass is density times volume, so density 1 gram per milliliter times 4/3 pi, and then the radius is going to be 100 micrometers times 10 to the negative 6, which gives us the meters. And we're going to cube that because that's part of the formula. A milliliter is a cubic centimeter, and there are 100 centimeters in 1 meter, so we cube that so that these cancel and these cancel. But again, we want the mass in kilograms, so 10 to the third grams in 1 kilogram, and grams will cancel, milliliters cancels here. And then so we'll get our mass in kilograms is 4.189 times 10 to the negative 9th kilograms. So when we plug this all in, we'll get 0.87 times 10 to the negative 4th meters quantity squared v squared plus 3.1 times 10 to the negative 4th times 10 to the negative 4th v minus 4.189 times 10 to the negative 9th kilograms times 9.8 meters per second squared. If you simplify this a little bit, you'll see that all of the terms have a times 10 to the negative 8th in them. So we can divide both sides by 10 to the negative 8th because that all equals 0. And then we'll get 0.87 v squared plus 3.1 v minus 4.105 equals 0. Then we plug into the quadratic formula, so negative 3.1 plus or minus the square root of 3.1 squared minus 4 times 0.87 times negative 4.105 divided by 2 times 0.87, and you'll only get one positive answer, and that's the velocity, which is going to be 1.03 meters per second. So that's part B. And finally, part C. So F equals ARV plus BR squared V squared. But the question says that we can eliminate one of these terms. So if we assume that the velocity will be greater than 1, then we know that this will be much less significant than this term. Also, the radius is larger, so the velocity is faster because the mass is going to be greater. Actually, yeah. So so we'll find the mass of a 1 millimeter raindrop. That's 1 gram per milliliter times 4/3 pi times 0.001 meters quantity cubed, and then 1 milliliter per 1 cubic centimeter, and 100 centimeters in a meter. And we want kilograms. So 1 kilogram is 10 to the third grams. If we simplify that, you get the mass is 4.19 times 10 to the negative 6 kilograms. So if we simplify this, we get mg equals br squared v squared, and v is going to equal the square root of mg over br squared. And I guess I forgot to mention, but down is positive because that's the direction of motion. So it's not plus or minus, it's just positive. And if we plug in the values, we'll get 4.19 times 10 to the negative 6 kilograms times 9.8 meters per second squared divided by 0.87 times 0.001 meters cubed or squared, and take the square root of all of that, and the velocity will be 6.87 meters per second. And yeah, so this is greater than 1, so we know for sure that this was the term that we were supposed to use. And that is number 59.